Okay, let's finally make our own version of this. So I'm going to really let go here, and I'm going to get rid of the STL library. Okay, so it's a little bit scary, but the feeling of raw power you will get when you implement your own data structure will make up for it, I promise. So, what do we need in order to create a linked list data structure? So somehow, we're going to need, I'll back up to where it was before. We're going to need some way of really some kind of wrapper class for storing objects that has pointers to other wrapped objects. And we're also going to need to know where to start. Okay. So let's think about the wrapper objects first. I'll try to put this picture up top to have in mind as I code a little bit here. So, okay, here we go. So the wrapper class that we're interested in, we're going to wrap around printable object references. So let me call this node. Or I guess I'll call it linked node. Okay. So this is going to be a wrapper class around some printable reference. That also holds arrows. Okay. So what I'll do is I will create, really, I guess I then need two variables, right? So one of them is the thing I'm wrapping. I'll just call it, I don't know, obj. So that's this is the object I'm wrapping. So it could have been, my int thing that was holding 0. Could be something else entirely printable. Then the other thing I need to store is actually a reference to another node. So I'm calling these again nodes. These are the wrapper things. And I'll call this next. So this is an arrow to the next object. Okay. And so what I'll do is I'll have the constructor take the reference to the object that I want to store in here. So I'll say linked nodes. Okay, so the constructor is going to take in the object that I want to store, and it's just going to store it. And it's also going to start off by setting the next arrow to be a null pointer. Okay. So it'll start off pointing to nothing. Okay. Now this is the only thing I need to do for this class. Okay, so it holds an object and it holds an arrow to another such wrapper node. Okay. Before I do anything else, let me just make sure that I can compile this right. Always want to write just a little bit of code and compile it right away. Okay, so it's having a lot of problems with this. Well, it's because I got rid of the list. Okay, so let me, I guess I need to comment out a good amount of this. I'll keep this kind of here for myself because I'll be writing similar code, but I probably should remove most of this for now. Okay. Let me now check and see. Okay, good, it compiles. All right, so all we've done so far is add this node class, but we haven't used it. So let's actually make the linked list class. Now the linked list class starts off very simple in terms of variables. I would actually challenge you to pause for a moment and think, what variable would the list need to have? There's actually only one. Okay, so pause. Really, it should just be the head, actually, because you just need to know where to start. Okay. So I'm going to make a linked node reference, which is the head of the list. Now, I should probably make this private, actually, because I might not necessarily want somebody outside this class to mess with what the head is. And I might not even really want them to know how I'm storing that, okay? Because they might mess things up for themselves if they're not careful. Okay, so anyway, what I'll do is make a constructor. And the constructor just starts me off with an empty list. So I'll just say head equals null, because it doesn't point to anything at first. Okay. All right, now eventually I'm going to want to add some other methods here. So I'll probably want a method to add a new object to my list. So I'll say add, maybe add first. Linked, or sorry, it's printable objects that I want to add. And so if I was going to add something, I would make a new node to hold it. And then I would put that somehow in the list. Okay. Now I'm going to leave this open for you to do. I'll describe in a moment how that works. But that'll be the exercise. For now, I'm going to do something very messy, and I'm just going to manually create this particular example here. Okay? Just so we have something small to work with. So in this example, I know that the head actually should point to so I'm also not going to worry about dynamic memory for a second. I'm not going to worry about memory leaks, but so I'm going to make a new node that holds an int that's 0. Okay. I'm going to make another node, and that is going to hold the number 1, and then I'm going to make another one that holds the number 4. Okay. So I have all these nodes, and now I need to link them together. So what I'll do is I'll just say, well, the head next equals node 1, right? So the head is pointing to this linked node that contains a 0. I want that next arrow to point to the node that contains 1. And then I want the next arrow of the node that contains 1 to point to the node that contains 4. Okay, so I've set up a very basic linked list here. This is not what we want to do, because really all the constructor should do is set up a null head, and we should actually go through this add method to add things. But again, this gives us something to start with. Okay. So the first thing maybe I'll do is add a method to print out the list. Okay. So what I'll do is figure out a loop to go through this. Okay, so what I have to do is really start at the head. I kind of have to do this iterator manually, right? So I guess what I'll say is I'll use the same names as I did before. So my iterator starts as the head, and then I'll say, you know, while the iterator is not null, well, then I can actually go through and pull out the object that I want to print. So then I'll say it object print. Okay. And then what do I need to do? Okay, well, I need to chase the arrow, right? I need to then say it equals it next. All right, so basically it is going, it's just like before, except now we're actually doing it ourselves, so you can really see how it's working with pointers. The iterator starts off pointing exactly to the same thing that the head does. We then dereference that pointer to the node from which we're able to extract the object it's wrapping around, and we know that these objects are printable, so then we can actually call the print method. Then when we're done, we can follow the arrow. Okay, so we follow this arrow here, and it takes us to here. And now our pointer is at this. We print it, we follow the arrow, and we are here. And then finally, on the next iteration, we're going to notice that the next arrow is actually null, right? So unless I told you otherwise, when I instantiate this linked node object, its arrow points to null, so to nothing. Unless I tell you otherwise. So here I actually changed the head to point to something else, and I actually changed node 1 to point to something else. But 4 still points to nothing, so my loop is going to break out at that point. Okay. So let's make sure that this incredibly complicated version of a program that prints 0, 1, 4 actually prints 0, 1, 4, okay? So what I'll do, I'm not going to worry about this for a second, but I'm just going to just create this object. So I'll say linked list array, and that's it actually. And I'll say array.print list. Okay. So let's try. And when we compile, we're going to get an error because actually I did not declare this class before I declared my linked list class, so it didn't make sense. It didn't know what it was at that point. So I need to actually declare my int wrapper before I then go and use it in the linked list class. So let me see if that did the trick. Okay, good. Good. So anyway, this program prints 0, 1, 4. How does it do that? Well, it's very complicated, but just to review one more time. I have these container objects, or these wrapper objects called nodes. They contain other objects, but they also contain an arrow called next, pointing to another container. When I string them all together, I make a list called a linked list. In order to go through all the elements in the list, I have to start at the first one, which is pointed to by a private variable called head. Okay, so head is always the beginning of the linked list. I manually set up some pointers here to go through wrapping objects that have 0, 1, and 4. And then I created this method printlist, which in general goes through and starts at the head and chases these arrows, printing as it goes along. Okay. So that was the very. So what you'll see in this class is like, okay, look, I knew how to do this program in 173. I could definitely write a program probably week 1 or 2 to print 0, 1, 4. What I'm showing you is how to redo these very simple examples with much more complicated things, not just for the sake of doing it, but because it will enable us to do more complicated things that we couldn't do with just what you knew in 173. But we got to start with some baby steps first. Okay, so here's our first baby step. So the one thing I want to add to this, I told you I wasn't worried about memory leaks for a second, but now I'm actually a little bit worried about memory leaks. So let me worry about that. Maybe I won't worry about this. Maybe I'll make it the responsibility of the person who passed these along to delete these, but I definitely should take care of anything that's allocated within the class. So normally these references would be passed along, so I shouldn't touch them. So the references to the things that I'm actually storing in this list. But this class creates new linked node objects, so let me try to delete those, okay? So when I have a destructor for a linked list, I need to make sure that I'm getting rid of all of these dynamically allocated nodes that I created. So what I'll do is I'll start at the head, and I'll say, okay, here's what I'll do. I'll say, while head is not null. Okay, so while node is not null. So I haven't reached the end of this list. Well, I guess I can say linked node next equals node next. So this is not null, so I should be able to dereference this and get to the next thing. So let me store that, and then I can delete this node. So I'm going to delete the dynamically allocated container. And then I'll actually change this pointer to be the next thing that I remembered. Okay. So I'm going to comment this out for a second and just notice the difference in how much memory is leaked here. So when I go to compile this, I'm going to do valgrind without that destructor. I see that I'm losing 96 bytes. Okay. But now when I have this destructor here, I see that program still works, but now I'm only losing 48 bytes. Okay. So I'm losing these ints, which I'm not properly taking care of yet, but I am able to at least clean up the footprint of this linked list method. Okay, so that linked list completely takes care of itself now. All right, but again, this is very unsatisfying. I don't want to add things this way. I would like it if I could actually add things with this method, add first. So let me set up code to do that, and I will have you actually finish the implementation of the add first method. So this is not going to work yet, but perhaps I can set things up for you. So I will say printable x equals new in wrapper I times I. And then I will say, well, this list I want to push back. Probably shouldn't call it error. I probably should call it I didn't want to call it list because that was kind of the name of another class, but I'll call it list. So I'll say list.add first. So maybe add at the beginning of the list this printable object reference. And then I'll say my list print list. Okay, so this should compile. It's not going to be very satisfying because I'm not actually doing anything yet. So it's not, okay, and we're leaking stuff because we haven't actually cleaned up the elements we've made, but anyway, it prints nothing. Okay. So let's talk about just pictorially a strategy for doing this, and then I'll set you loose on it. So when we start off our linked list, it starts with a null head. There's nothing there, right? So the first time we go and add an object, okay, so we always want to create a new node, right? If the head happens to be null, well, actually, we can just make the head this node. So that's the first step. So now, actually, I go and I add in this program, I add the number 0. And so what's going to happen is, okay, now I make a new node that wraps around 0, and my head becomes that. Okay. So if there's nothing in the list, then the new thing I create becomes the head. If I go to compile this, I'll see that now it prints 0. Okay, cool. I'm getting there. So that's one, we call it an edge case. That's one special case there. But in general, the head's not going to be null. So what you have to do is figure out how to make this object the new head. So I actually want you to think about this a little bit. It's just a couple of steps. You shouldn't need any loops or anything like that. But this new node that you've created needs to be inserted. The head needs to become this, and then its next should point to what used to be the head. So I'll follow a few of these through. So let's say that next I wanted to add the element, I'll say 174 at the beginning. Okay. So what I'll do is I'm going to create a new node that holds 174. And really what I should do is, okay, I know that this is supposed to go at the beginning of the list, so I should have 174 as next point to what's currently the head, and then I reassign the head to be this new thing. All right. So that was me adding 174 to the beginning. Let's say that I now wanted to add 371 to the beginning. So I do much the same thing. I would say, okay, currently the head is 174, but I know that my new head is going to be 371. So I will say, well, after that, the next thing that I should visit is what used to be the head, so 174. And I will make the head now point to the beginning of 371. Okay, so you see what's happening here? Every time I create a new node that contains my object, I make that node point to what's currently the head, and then I change the head to be the new node. So that's what I want you to do. And once you've done that, you have an honest to goodness linked list. You have the basic functionality to at least fill the list and then print things. We'll talk about removing in a second. But to give that a shot, and let me know on Discord if you have any questions.